Okay, so how much do samples vary? The variation is important. The less it varies, the better. So we try to get to that closest to that number we're looking for if there's a specific number. Okay, so let's look at this particular example and just analyze it. This is not a downright question. This is what do you see, but we'll just discuss it together. So suppose that 70% of the students in a large university attended all their classes last week. So 70% attended all classes last week. Imagine taking a simple random sample of 100 kids. And universities are huge. Usually there's a lot more people in it. So thousands we're talking. In Colorado State University was like over 30,000 kids, basically. So some of them can be giant. Sample of 100 students and recording the proportion of the students in the sample who went every class last week. Would the sample proportion be exactly 70? So if I took a sample, will that be exactly 70% of kids went to all their classes? The answer is no, probably not, because we're taking a sample. So the sample could be kids who missed a class or didn't miss a class, or there could be more. The number of kids who attended all their classes might be 50%, might be 40%, depending on the sample. So would the sample proportion be exactly 70? Probably not. Would the sample proportion be close to 70% or 0.70? It depends on what we mean by close, okay? So the following graph is showing 500 simple random samples. So let's say I took 100 kids sample, that's one time. And I got the proportion, the percentage of kids who went to all their classes. Then I took another. Then I took another. Then I took another. Then I took another. And I did this 500 times because I don't have a life and all I want to do is take a sample of 100 kids from a university over and over again and to ask them questions. They better pay me a lot of money. This is what it would look like. The dot plot. If we made a dot plot, it would look kind of like this. All right, and you could see that the variation is anywhere from like 55% to about 85%. So like it's 55% to 85% went to all their classes last week. Okay, not just 70, but then look at the middle. The middle is kind of right around 70. The true value is 70%. And this data reflects that, yes, on average, the center of this curve, which looks like a bell-shaped curve, which is like a normal distribution, is 70, but the variation is from 55 to 85. That's like a 15% variation. So 15% margin of error, there's always going to be a margin of error. Okay, why? Because, 70 minus 55 and 85 minus 70 is 15%. So give or take, this is not a mistake. This doesn't mean a mistake, not a mistake. You've heard of this word before, maybe, and maybe not. If not, margin of error just means give or take. Give or take, they say. Like a little over, a little under. It could be over or under about that much on average. Okay? And that's it from here. So, what's important? What's important is the center of dot plot is very close to the actual 70%. All right. This accuracy comes from using simple random samples. Okay, simple random samples removes bias. Okay, so we're not consistently, we are not consistently underestimating or overestimating. Okay, that is important. Okay, all right, and that's it. And so how do we really, like, the most important thing is we're going to do inference. And inference is we're going to take samples and we're going to make judgment calls, assumptions, predictions about a whole population. All right, and this is called inference because we're inferring information about the population from it. And sample results will differ somewhat just by chance. There is a chance that it's going to be different and it's not going to be exact. But properly designed samples avoid systematic bias. That's completely the hardcore important part here. And their results are rarely exact, but we expect some variation basically from sample to sample, and that's okay.